Hello everybody, I'm Gerald and I'm going to present the bitkanone today. So these are the first two prototypes in their second revision. I just added the frame recently. Unfortunately I also had to install this fan here to keep down the temperature if all the LEDs are cranked up to the maximum brightness. These are actually two separate units. Each of them is powered by a PSU which supplies 30 watts. So quite some power hungry LEDs we got there. This is just a plain WS2812B Led-Strip with 5050 LEDs on them, and over there we got the controller, which is just a TV launchpad. Now on this TV launchpad there is Forth installed, which is operating system, compiler and language in one, and we will work directly on that chip without any IDE, just through a plain terminal connected through this USB here. Okay, so much about the hardware. Now let's see what this thing can actually do. It's hooked up to the computer, and once we power it on, it will display a test pattern very briefly. And then there is a green LED at the very bottom. And if it receives any characters through the terminal within the first 5 seconds, it will turn red and you can interactively program it. But unfortunately, Modem Manager just did this. So let's wait for Modem Manager to finish his pseudo detection, and I guess we're done. Let's reset it again. And if we do not interrupt it and do not send it any signals, it should start. Yeah, and it does. So what you can see here is a Game of Life glider. And it is not just two colors. If a cell lives for multiple generations, it becomes more yellowish. And if a cell dies, it slowly fades to black. Now here's some markup text with different colors, followed by some very white text, and we are just about to be raided by the cat who wants to be in this video so badly. So let's just give it this moment. Alright, camera restored. So what we can see here is the demo continuing. So the bitkanone is just introducing itself for the Maker-Faire. It's in German because I expect most of the folks there to be German speaking. And again, we can see the different markup and it scrolls. It does not look nearly as nice on the camera as it does in real time. So let's just go on and hack a little bit on this thing itself. Alright, so let's reset the device so we can start hacking. Press any key. Here we go. Now we can type off. All LEDs are off. And if we type on, all LEDs will be at the maximum brightness, which the camera can unfortunately not pick up. It just gets all blurry, but this is insanely bright. Remember, it's 60 watts of LEDs pointing right at the lens. Of course, we also got other color primitives like blue, red, and green, so we can do something useful right out of the box. And let's just start by implementing a subset of Morse code. So in Forth, definitions start with a colon. So here we define a word which we call did, represented by a dot, which then just calls other words which are already defined, like green. Then we wait for 100 milliseconds, then we turn it off, and then we wait for 300 milliseconds. We end the whole word definition by a semicolon. And this then becomes a word by itself. So if we now just hit the dot button, of course followed by enter, you can see it just blinks one time. And we can also implement S, which is just 3 dits. And if we now type S, enter, it blinks 3 times. So now we're going to define the dot symbol, which is the long period represented by a minus, and we're going to use cyan, so we make it even more distinctive. And of course it also has to be longer, so we make the on period 300 milliseconds. Now we can just go ahead and define the O by using just dots 3 times, which makes it again an easy accessible word. So if we type O, it should blink 3 times slower. Now we can define SOS by calling S, O, and S. And if we type this, we get the complete Morse code going. And it could go on for this for the whole alphabet. Now for the last part, we are going to be playing with the Game of Life simulator. And let's just start by using the famous glider. And of course, we also want to see it moving, so we type 10 call steps and it will iterate 10 simulation steps and then just stop. We can also have the light white spaceship, and let's have it travel to the right for 20 steps. So you see, with Forth you can not only debug directly on the chip, you can also write the whole program there. It's just a much deeper integration than with lots of other languages. So if you'd like to dig deeper into Forth, just come and visit us at the Maker-Faire in Hannover. I won't be there, but my friends will be there and they'll be glad to get you started. Alright, have fun, goodbye.